Let's discuss this question next. What does the question say? 11th, tan inverse of root plus 1 plus x minus root of 1 minus x over similar expressions in the denominator, that is root of 1 plus x plus root of 1 minus x is equal to pi by 2 minus half cos inverse x, where minus 1 by root 2 is less than equal to x is less than equal to 1. There's some interval of x also given. And this one special thing which is given over there, which will help you solve this question. But had this thing not been given, what thoughts would have occurred to our mind? You observe this cos inverse x with a half. Yes. If this is some angle theta, right? Well, imagine this is some angle theta. So 2 theta will be equal to cos inverse x, and x will be equal to cos 2 theta. That's the idea that we'll get from here about the substitution of x for simplifying this, right? You can imagine half of cos inverse x, if this is equal to theta, cos inverse x will be 2 theta, therefore x will be cos 2 theta, and that's the substitution that we want to use. Now the benefit of that substitution, let's see, this is 1 plus cos 2 theta, right? What does 1 plus cos 2 theta simplify into? This is something which we have studied in trigonometry, and let's see what does 1 plus cos 2 theta simplify into. This is 2 cos square theta. What about 1 minus cos 2 theta? This also simplifies into 2 sin square theta. Okay. So I observe that this will be cos theta minus sin theta, cos theta plus sin theta. There will be root 2 or something, but those will get cancelled. So cos theta plus sin theta, cos theta minus sin theta over cos theta plus sin theta. This is something which is again borrowed from trigonometry, concepts from trigonometry. I can divide by cos theta sin theta, I can write it as 1 minus tan theta. Dividing by cos theta, this can be done as this. And this further can be observed as tan pi by 4 minus tan theta, 1 plus tan pi by 4 times tan theta. Tan pi by 4 is 1, right? So this is tan pi by 4 minus tan theta, 1 plus tan pi by 4 tan theta, which is tan of pi by 4 minus theta. I'll write all of these steps over here again, but then these are the ideas that we are borrowing from trigonometry for solving this question of ITF, right? Let's see this question. Let x equals cos 2 theta. If we begin with this, the LHS can be simplified into what? Tan inverse of, you have a huge expression over here. What is that? Root of 1 plus x, which will be written as root of 1 plus cos 2 theta. Minus root of 1 minus cos 2 theta over similar terms in the denominator separated by a plus sign now. This is what you have, right? This is further equal to tan inverse of, what is this? This is 2 cos square theta. And can you guess the values of theta? From here. Let's also calculate the values of theta, guess the values of theta from here. We have cos inverse x by 2 equals theta, or cos inverse x equals theta. If x lies in this interval, minus 1 by root 2 to 1, you remember the graph of cos inverse? Yes, this is the graph of cos inverse. It is a decreasing graph, okay. So the lowest value will be cos inverse 1, which is 0, is less than equal to 2 theta, is less than equal to, we are talking about cos inverse x, right? 0 is less than equal to 2 theta, which is less than equal to cos inverse of minus 1 by root 2. Now minus 1 by root 2 is somewhere here. So this is minus 1 by root 2. The output is pi by 2 and pi. The middle of pi by 2 and pi, that is 3 pi by 4, right? Okay. From here I can guess the values of theta. This is range of theta values. This is 3 pi by 8. So theta lies from 0 to 3 pi by 8. Okay. 0 to 3 pi by 8 is actually 3 pi by 8 is less than pi by 2. This is still in the first quadrant. We are still dealing with first quadrant. Okay. So this is root 2 cos square theta. The under root will be equal to modulus of cos theta, which is simply cos theta, right? Since theta lies in the first quadrant. So this is root 2 cos theta minus root 2, same thing. This becomes sin theta. Once again, first quadrant, sin theta will open as positive. Modulus of sin theta will be sin theta. This is again same terms in the denominator. Similar terms in the denominator, but separated by a plus sign this time. Root 2 plus. Now can I divide by root 2 cos theta in the denominator and numerator both? Yes, I can do that. Let's do it. 1 minus tan theta over 1 plus tan theta. This is what I get by dividing numerator and denominator by root 2 cos theta. What next? This will further be equal to tan inverse of, do you observe that 1 is actually tan of pi by 4? Oh, we already saw that over here. Yes, I am writing that exact same thing, something which we already remember. I am expressing that again over here. This is tan theta 1 plus, this is tan pi by 4 times tan theta. Tan pi by 4 being 1, we can multiply by 1 very easily, right? This is equal. This becomes tan of pi by 4 minus theta. Yes or no? Yes. Now what about these values of pi by 4? This value pi by 4 minus theta. Since theta lies in this interval, we know that pi by 4 minus theta will lie in the greatest value will depend upon the least value of this. This is pi by 4. And the least value will depend upon this 3 pi by 8 over here. Pi by 4 minus 3 pi by 8, which is 2 pi by 8 minus 3 pi by 8. This is minus pi by 8. This over here. Is that okay? Yes. Minus pi by 8 to pi by 4. This is pi by 4 minus theta. From this to this value, this is fourth or first quadrant only. In fourth or first quadrant, tan inverse of tan x is simply equal to x. Therefore, this is pi by 4 minus theta. Now what is theta? 2 theta is cos inverse x. Theta will be half of cos inverse x. S inverse x. This. And yes, this is my RHS. That's a complete proof of this question over here. That's a complete solution for this question over here. Proof? Yes. Is that all? Yes.